Hi guys, Audrey here. So today we're going to talk about geometric series and whether or not they converge or diverge. So here's what we know. A geometric series, sum n equals 1 to infinity, a r to the n minus 1, converges to a over 1 minus r if the absolute value of r is less than 1. So that's if the r is between -1 and 1. And it diverges if the absolute value of r is greater than 1, greater than or equal to 1. So if r is less than or equal to 1 or greater than or equal to 1. Less than or equal to -1. So with that in mind, what that means is in order to determine if a geometric series converges, we just have to find r. Now remember, r is the number that we're multiplying by each time, and a is the first term. So let's go down and see if we can figure out if this geometric series converges or diverges. The first thing that we're going to do is find a. Now, if a is the first term, what that means is it's going to be the first thing that shows up. Well, the first thing that shows up can be found by plugging in whatever number shows up right down there. So a typical geometric series will start with 1, but a lot of times you'll see them starting in other places. This one starts at 2. So what that means is to find a, I'm doing 3 to the 2 minus 2 over 5 to the 2 plus 3. 3 to the 0 is 1. And by 2 plus 3, I definitely mean 2 plus 1. So that gives me 5 cubed, which is 1 over 125. Now, for our r, we really have two ways to do it. There's a really simple way, which is to look and say, what do I have to the power of n? Well, in the numerator, what I have to the power of n is just 3. And in the denominator, what I have to the power of n is just 5. If you need to rewrite to see this, you can. We can use exponent rules. So 3 to the n minus 2 over 5 to the n plus 1 is equal to 3 to the n times 3 to the negative 2 over 5 to the n times 5 to the 1. Notice the thing in the numerator to the n is clearly 3, and in the denominator it's clearly 5. Okay, so that's one way to find r. Another way to find r, if you find it a little bit challenging to be like, what's to the power of n, is we can do the ratio of the first two terms. So we already have our first term, that's our a, 1 over 125. So now I'm gonna plug in 3. So in other words, the next value. So a of n equals 3 will give me 3 to the 3 minus 1 minus 2 over 5 to the 3 plus 1, which is giving me 3 over 5 to the 4th. Then I can do the ratio of that with the previous term. So 3 over 5 to the 4th. My first term was 1 over 5 cubed. So this is 3 over 5 to the 4th, 5 cubed over 1, which gives me 3 over 5. And notice we found r, we found the exact same r, just in a little bit of a different way. Okay, now that we have that, we have our a, we have our r, we need to know if this king converges. So we said r is equal to 3 over 5. The absolute value of r is indeed less than 1, which tells me that this converges to a over 1 minus r. My a was 1 over 125. My r was 3/5, so that's 1 minus 3 over 5. And we'll simplify this. So that was 1 over 5 cubed. 5 over 5 minus 3 over 5 is 2 over 5. So I have 1 over 5 cubed. Division by a fraction is the same thing as multiplication by the reciprocal. So this gives me 1 over 5 squared times 2. So then this converges to 1 over 50. And that was pretty straightforward, largely because it was so easy to find r just by thinking of what was to the power of n. All right, so in the next question, we're going to do a problem where maybe it's a little bit more challenging to find r. Okay, so it's only going to be an itsy bitsy little bit more challenging to find r. We're still just going to have to think about one extra little thing. So as we said, the first thing that we want to do is find a. A comes from plugging in whatever value we have right there. So in this case, the value that we have right there is 5. So that means on top, I have 2 to the 3 times 5 over 4 to the 5 minus 3. So that's 2 to the 15, and I'm just going to leave that like that because that's going to be a really big number. And then 5 minus 3 is 2, so that's 4 squared, which I could simplify to 2 to the 15 over 16 if I wanted. I could also cancel out some 2's if I felt like it. I'm going to leave it like this for the moment. We'll deal with that at the end if we need to. Okay, so then the next thing is, what is r? Well, we said r is the thing to the power of n. So in this case, when I'm looking at the numerator, the thing to the power of n is not just 2. I need to take that 3 with me. So this is 2 cubed over, in the denominator, it's just 4. So we'll do some exponent rules just to see why that's the case. 2 to the 3n is the same thing as 2 cubed to the n. So clearly in the numerator, we have to take that 2 cubed. And 4 to the n minus 3 is 4 to the n times 4 to the negative 3. So again, the thing to the n down there is also just 4. Okay, so I am going to simplify this now. So in other words, I have 2 cubed on top. 4 is actually just 2 squared, which means that my r is actually 2. So again, before we go on and make any conclusions, I'm going to find r in a different way. We're going to find r by ratios. So I already have that a is 2 to the 15 over 16. So when I plug in 6, I'm going to get 2 to the power of 3 times 6 over 4 to the 6 minus 3. So that's 2 to the 18 over 4 cubed. Now for my ratio, that means I'm doing 2 to the 18 over 4 cubed divided by 2 to the 15 over 4 squared. So that gives me 2 to the 18 over 4 cubed. I flip the denominator because I'm dividing by a fraction, 2 to the 15. So here I can see some of those 4's cancel out, and then 18 minus 15 is 3, so that means I have a 3 left up here. So this is going to be equal to 2 cubed over 4, which is what we had up there, 2 cubed over 4, which is just 2. So we ended up in the same place as we were up there. Now, does this converge or diverge? Well, in this case, my r is equal to 2. So the absolute value of r is greater than 1, which implies that this diverges. I do not have to simplify anything. The answer is just diverges. Okay, so we're going to look at one more problem where one more interesting thing happens, and then hopefully you'll be comfortable with all geometric series since they're all pretty similar. All right, so the first thing to notice about this problem is that we have this plus sign right there. Now this plus sign is the thing that's stopping this from being a geometric series. So I'm going to take it and I'm going to separate it into 2 different series. So I'll get the sum n equals 1 to infinity, 5 times 6 to the negative 2n, all over 2 to the 3 minus n, plus now I'll have this new series n equals 1 to infinity of 2 over 2 to the 3 minus n. Now I could simplify things, especially on the right side with that 2 over 2 to the 3 minus n, but I'm actually just going to leave this as is for the moment. Okay, so we have these 2 different series. I want to figure out separately if each of them converges or diverges. So we're going to call this one smiley face, and we'll call this one round face. So for smiley face, we're going to find our r, and we're going to find our a. So our a is going to come from, as usual, from plugging in that first value down there. So I'm just plugging in 1. So my a is equal to 5 times 6 to the negative 2, all divided by 2 to the 3 minus 1. So this is 5 times 6 to the negative 2 over 2 squared. Well, that exponent of negative 2 means to bring the thing down to the bottom. So this is 5, divided by 2 squared times 6 squared. Again, I'm gonna leave this like this till the end. I could do like 36 times 4, get an actual value, but I might not need to if we find out that one of these things diverges. So that's my A right there. Now for my R, remember we're looking at the things that are to the power of n. In this case, we have that negative 2n, so that means it's 6 to the negative 2. And on the bottom, I have 3 minus n, which means that it's 2 to the negative 1. I'm going to simplify this, and then we'll see why we took those negatives. We'll do some little exponent rules. So the 6 squared goes to the bottom, and the 2 goes up. So this is like 2 over 36, which is the same thing as 1 over 18. Now, just to make sure that we get that, the 6 to the negative 2n, remember that's like 6 to the negative 2, all to the power of n, and 2 to the 3 minus n is 2 to the 3 times 2 to the negative n, which is 2 to the 3 times 2 to the negative 1, all to the n. So I can see that I need to take with me the 6 to the negative 2 and the 2 to the negative 1. So in this case, my R, my absolute value of R, is equal to 1 over 18, which is less than 1, so it means that this thing converges. However, before I decide what it converges to, I'm going to go look at round face. And the reason that I'm going to do that is because I know that if I have converges plus diverges, then the whole thing diverges, and I don't need to know what that first part converges to. So we're going to look at round face and just see what's going on over here. So for round face, we see that A, again, I'm just plugging in 1, is 2 over 2 to the 3 minus 1. So that's 2 over 2 squared, which is just 1/2. That was pretty straightforward. Now for my R is going to be equal to, notice in the numerator, there is a nothing to the power of n. There's just a 2 up there. So if there's nothing to the power of n, that means I'm just going to put a 1 there. And the denominator, it's going to be 2 to the negative 1. So that 2 to the negative 1 is for the same reason that it was over there with smiley face. But what that ultimately means is that my R here is 2. So the absolute value of R is greater than 1, which means that this diverges. So what we have is converges plus diverges. And what that means is that the whole thing diverges. And a good way to think about that is if you have some finite number like 5, and then you add infinity to it, well, that 5's not really changing the infinity. It's still going to be infinity. So converges plus diverges will always give me diverges. And the final answer here is that this thing diverges. That's all. Bye, guys.